There are many questions related to logarithmic functions in LCAT, and in order to solve them, you must have the proper understanding. The basic definition of a logarithmic function is log with a base and a number. Now, what does it mean? The base means you have to raise it to some exponent such that the result is equals to x. Hence, a to the power of x is equal to a. A simple example could be if I ask you to find log with base 3 of 9 is equals to what? What I am asking here is that what is the power of 3 which will equate it with 9? And you know that 3 squared is equal to 9. Hence, the answer of this question would be 2. Similarly, if I ask you to find log with base 2 of 8, what I am asking here is that what is the power of 2 which will make the expression equal to 8? So 2 raised to power what? Such that is equals to 8. As you all know, 2 cubed is equals to 8, and the answer of this would be 3. The same happens if you take 10 as the base. So 10 is a common base, and you may or may not write it down because it's understood that it's here. So what is the power of 10 such that the expression is equal to 100? Obviously 2 because 10 squared is equal to 100. 10 to the power of 2 is equal to 100. Now, whenever you see a question which does not specify its base, for example, it asks you to find log of 1000 and they have not provided any base, it's understood that the base is 10 because that is the common log. That is understood that 10 is there unless taking otherwise. Hence, in this case, since 10 cube is equal to 1000, the answer would be 3. After getting an understanding of the basic logarithmic function, now it's time to understand a few rules. There are 4 rules in total. The first one is called add the product rule, where you have two numbers multiplied with each other. In that case, you can just write them separately with a plus sign in between. Note that I did not write the base here because I'm assuming it's a common log. This rule is also true for any base, so I'll also write down base here. So any base will fulfill this relationship. So if the examiner asks find log of um, let's say find log of 18 and the base is 3. Now you know that if it was 9, the answer would be 2, but you're not sure for 18 because uh, no integer power of 3 gives you the answer as 18, right? Because 3 to the power of 1 is just 3, 3 squared is 9, and 3 cubed is 27, so 18 is not there. But you can use the product rule to get a simplified answer. That is, you can write it down as 9 times 2. The benefit is that now you can separate them, and you know that log for 9. So the answer would be 2 plus log 3, 2. Next, we have division rule. So in this case, you have a negative sign in between of them, and the days remain the same. So these several questions are again helpful in simplifications, whether it's in terms of variables or in terms of constants. For example, if I so how can you simplify the expression? These are all um, the variables. You don't know the values for m and n, right? So in this case, this rule comes handy. So you apply the division rule, you get log m minus log n plus log n. You cancel out, and the answer is log m. Similarly, if you have an expression like find a log of 500, and since the base is not specified, it's understood that the base is 10. So we don't know the answer 500 because obviously 10 to the power of 1 is 10, 10 square is 100, and 10 cube is 1000. So none of them match with the 500. So what we can do here is that we can write down 500 as 1000 divided by 2, and then after the separation, we can get a simplified answer. Looking the MCQs, the options rather you might have this one. Just let's show it and move forward to the next question. The next one is the power rules. The rule states that if you have a power on the variable, so and a to the power, and then you can just simply write down the power at the left side of the log and multiply it. So you don't have to worry about how to solve a to the power of n because you don't have to just take the log of a simple and then multiply it with that. And this is very helpful, especially when you have to solve problem like solve so 9 to the power of 10. That's kind of a very big number. If you first have to calculate 9 to the power of 10 and then find the log, that would take a lot of time. But thanks to this rule, now you can just write down the exponent at the left hand side and then solve the log. Since 3 squared is equals to 9, the answer would be 2, and hence the overall answer would be 20. The last rule is somehow unique rule. It's about change of basic. So it often happens is that there's kind of an odd base which you don't know how to solve it, and you just want to change the base, or maybe you want to add all the variables and you just want to cancel out something. That's why you're looking for a same kind of base among all the numbers. So what this can tell you is that if you have a log, you can just write it equals to log a divided by log of base. Yeah, that kind of base is kind of a variable. And for these two logs, you can have any new base, whatever you want, so new base. Or you can make it a common log, a natural log. By the way, a natural log is the one where the base is e. So log e to the a, it would be a natural log. So for MCQs, it appears. All right. So how can we use this change of base? Just take the same example I just showed you. That was, for example, if you have to find log e of 2, you don't have the calculator, you don't want to solve it, you can just change the base. You can just do log 2 divided by log e. Now you can choose any base of your choice. You want to choose 2, you are welcome. Or if you want to choose 10, that's also fine, it works. But if you choose 2, then the 2 to the power of 1 is equal to 2, and the answer would be 1 in the numerator. And for the denominator, you can just write as it is, and you can just look into the MCQs. You would find this